Hey guys, welcome back to my YouTube channel. Today I'm going to be showing you how to evaluate this integral, right, this definite integral using a substitution. So first we have to determine what we want to let, right? So for substitution, you want to let u be equal to something, right? Something in this expression right here. I also have another video explaining integration using a substitution, but for indefinite integrals. This is for definite integrals, so you can see there will be bounds here that we need to substitute in. It's quite similar to the indefinite one, but there is a bit of a slight difference in that. So anyways, but something in common is that we need to choose something to be equal to u. So how about we choose cos theta minus 2. So cos theta minus 2 is equal to u. So once we do that, we need to find a derivative of that. And we will get, well, we know the derivative of cos theta is going to be negative sine theta. The derivative of negative 2 is going to be 0, so it's going to be plus 0, but I'm not going to write that. So we just know the 0 is there. So anyways, so from here, we want to get rid of d theta, basically, right? We know this is going to be replaced by u, this denominator right here. D theta we need to get rid of, and also sine theta. But hey, we also have sine theta here too. So we could get rid of it. We could get rid of the sine theta, because we're trying to change all the thetas to basically u's. So here, we can recognize that, okay, well, there's a sine theta right here. Let's rearrange this, right? So rearranging it, let's multiply both sides by d theta. And why do we do that? Well, we want to match it up with this portion right here, right? We want to match up with this so we can substitute something in for this circled portion. So multiplying both sides by d theta, this crosses out. Then we get du is equal to negative sine theta times d theta. So du is equal to negative sine theta d theta. And then we see here, well, this is not matching up with the circled portion because of the negative. So what we're going to do is we're going to multiply both sides by negative 1. So multiplying both sides by negative 1, this side is going to become positive and this side is going to become negative. So basically negative du equals sine theta d theta, just like that, because we multiplied both sides by negative 1 and we got this, right? So we can say that sine theta d theta is equal to negative du, and that means we can substitute this part in for the circled portion. So I'm going to substitute that in, right? And I'm going to substitute u in for cos theta minus 2. But also don't forget we have these bounds here. We also need to change these up as well because we are using a substitution. So now we need to basically change these up. And how do we do that? Well, we know u is equal to cos theta minus 2, right? These values are actually normally for theta, right? We need to sub it in for theta. We can find an integral of that, but we need to use a substitution in this case. So instead, we are going to plug these into this formula right here, right, for theta, and try to find the u values, right? The values for u using these values of theta. So let's do this. If theta equals 3 pi over 4, right? I'm going to use the higher bound first. Then what's u going to be equal to? Well, if we sub this in, u equals cos theta, which is 3 pi over 4 minus 2, right? And here we have, well, we can recognize that we can use the casserole CAST, and this is 3 pi over 4. So we know this is 4 pi over 4 here, right? If we go all the way here, but then it's only part of it. So if we go all the way here, it's going to be 3 pi over 4, right? This bullet part is going to be 3 pi over 4. And we know 4 pi over 4 minus 3 pi over 4 is going to give us this leftover part, right? So 4 pi over 4 minus 3 pi over 4 gives us pi over 4. And we know we can use special triangles for this. So special triangle. So this is pi over 4. This is pi over 4. This is 1, square root of 2. And then we know, okay, cos, right? So cos is 1, right? So adjacent, let's look at this angle, adjacent over hypotenuse, so 1 over square root 2. So we know that cos pi over 4 is equal to 1 over square root 2. And so we can use pi over 4, right? But then we have to recognize that this is s, right? So all the signs are positive, so that means cosine will be negative, okay? So that means it would be negative 1 over square root 2. So this here would be negative 1 over square root 2 right here, and then minus 2, just like that. So we found our u for this upper bound. Now, how about the lower bound? So if theta equals the lower bound, which is pi over 2, then what is u equal to? Well, we can just basically sub this into u equals cos theta minus 2. So u equals cos theta minus 2. U equals cos theta. Theta here is pi over 2. So pi over 2. U equals cos theta minus 2. Right out from here, and then once we do that, we're just going to simplify. So we know cos pi over 2, right? Cos pi over 2. Here it's 0, 1, right? This is pi over 2 here, right? So x is 0, and then here it's 1, so 0 over 1, right? So 0 over 1, so cos pi over 2 is equal to 0 over 1 minus 2, and that's going to be equal to 0 minus 2, which is equal to negative 2. Alright, so we have found this value right here, right? Negative 2, okay, for if theta equals pi over 2, and we also found the value right here, right, for u, if theta equals 3 pi over 4. So what we're going to do is we're going to write these new bounds into our integral. So here, the new upper bound, 3 pi over 4, it corresponds to negative 1 over square root 2 minus 2. So I'm going to sub this back in here. Negative 1 over square root 2 minus 2. And then here, this new bound, pi over 2, we basically got negative 2, right? So negative 2, because now everything is for u. These are the u values, and now we have to change these to u as well. So here this is going to become u, and it's in the denominator, so we're going to write 1 over u, and then sine theta d theta, right? This we got to be equal to negative du, so I'm going to sub in negative du just like that. And we can recognize we have a negative here. So it's like negative 1 times this entire thing. So why not bring out this negative 1 in front of the integral sign? Okay, so I'm going to bring this negative out. Just like that, and just copying this part. So 1 over u du. Okay, so now it's going to be easy to integrate this. We can find the integral of 1 over u. Now, what is the integral of 1 over u? The integral of 1 over u is basically ln absolute value of u, so I'm going to write that in, so negative, we're going to get rid of the integral sign, so negative ln absolute value of u, just like that, and our bounds here, negative 1 over square root 2 minus 2, negative 2, okay, we're writing our bounds like this now, okay? And so we have integrated, and we don't need to write the constant c because this is a definite integral. With indefinite integrals where there are no bounds, we need to write the constant c, like plus c, but here we don't need to. So that's a difference there in comparison to my other video on substitution for indefinite integrals. So anyways, carrying on here, what we need to do next is we need to substitute these values in for ln absolute value u. So we have the negative here, copy that. I'm going to write square brackets. So ln absolute value u. So first we must take this, substitute it in, substitute this in for u, right? Substitute this in for u, okay, the upper bound. And then now subtract ln and substitute -2 in for u here. So write in -2 like that. And we have this. So here are the absolute values. I'm just going to bold it in so it looks less confusing. So here's an absolute value surrounding the first value of u from the upper bound. And then now the second value of u from the lower bound is -2. And then from here, you're just going to simplify this. So this is negative, right? And then ln. And this is absolute value. Well, this is all negatives. We can basically factor out this negative. So I'll show you what I mean. So absolute value here. Factor out this negative like that. So negative times 1 over square root 2 gives negative 1 over square root 2. Negative times positive 2 gives -2, right? You can see if you distribute this negative in, you will arrive back at this. And then here we recognize, okay, negative ln. Here we can recognize that -2, right? The absolute value of -2 is going to be equal to +2 because it's an absolute value. So this has to be 2. So instead of -2, we're going to write 2, just like that. Okay. And then we can apply the same thing right here. You see this negative? So this is a negative value of this, right? So we want the positive part. Okay, we want the positive part because it's an absolute value. So we're going to write the positive part. So this is equal to negative ln. Now we can get rid of the absolute value signs. Once we do that, kind of like how we did here, right? We got rid of the absolute value signs once we changed it to positive. So get rid of the absolute value signs, get rid of the negative signs. So 1 over square root 2 plus 2, close bracket, minus ln 2, close bracket, just like that. And now let's apply the distributive property into each of these terms. First negative, so it's going to become negative ln 1 over square root 2 plus 2. Then this negative goes to this negative, so positive ln 2. So this is ultimately equal to ln 2 minus ln 1 over square root 2 plus 2. Right, I basically rewrote this, writing this first, then writing this afterwards. And then what I can do here is I can basically change up the denominator here, right? I can simplify this part, so I'm just going to simplify this on the side. So 1 over square root 2 plus 2, we want to simplify this part. So I can recognize that we don't really want the square root 2 in the denominator, so I'm going to just multiply by square root 2 here and right here. So I'm going to get square root 2 over square root 2 times square root 2 is going to give me 2, and then plus 2 right here. And then I can recognize that this is 2, right? It's the same as 4 over 2, so we get a common denominator. So this is 4 over 2, right? So I multiply by 2 here and here, okay? So I got 4, and then this 2, and then this becomes square root 2 plus 4 over 2. So I can rewrite this part as this part that I found right here. So I'm going to do that, make it look a bit nicer. That's why I'm doing that. So this is equal to ln 2 minus ln square root 2 plus 4 all over 2, close bracket, just like that. So yeah, so this here I have basically found the definite integral for the following integral here. So to recap, what we need to do when we do it using substitution, we need to basically let, right, we need to find a part of it to be equal to u, okay? So once we find a part of it to be equal to u, we have to also find a derivative of u, so we can basically substitute this part, right? Because from this derivative, we basically arrived at what sine theta d theta is equal to. And then these bounds, you must change it. A common mistake people make is they forget to change these bounds. To change these bounds, we need to change it by substituting in the values of theta into here, right, to get u. And then from that, we basically integrate as usual, okay? Once we substitute this stuff in, we take out this negative first, of course, because it makes it easier. So once we integrate that as usual, we don't need to add a constant c because it's a definite integral, and we just substitute these values in, these new values of u that we found from here, right, using this equation. We substitute that in, and then we basically arrive at our final value. So yeah, this is the end of my YouTube video. Thank you for watching. If you enjoyed this video, feel free to give it a big thumbs up, and also feel free to let me know in the comments down below what you think about this YouTube video. And of course, if you are new to my YouTube channel, by all means, feel free to hit that subscribe button and you will get lots and lots of videos with math help. So anyways, I hope to see you all next time for another math video. And I hope you have a nice day. Bye!